We're going to finish off vectors, okay, and then we're done. And then we're actually done, okay. So what I'm going to do is I'm going to take you through the examples in the textbook. So you need to be on page 238, all right. Example 6 is what I'm going to do in this video, all right. So I'll read out the example first of all, then talk you through it. So in triangle OAB, the midpoint of AB is M, OA is X, OB is Y, OD is 2X, and OC is 2Y. We need to express AB, OM, DC in terms of X and Y. And then finally, we're asked, what do these results show about AB and DC? Okay. Right, so I've drawn a triangle on the board, okay? So that's the first thing you want to do with any vectors question, okay? If you're given a diagram, great. If you're not, then you need to draw one. You really need to draw one, okay? So when it says in triangle OAB, draw triangle OAB, okay? And it says OA is X, so I've labelled that already, vector X. OB is Y, so I've labelled that already. And it also says the midpoint of AB is M, so I've labelled that. Now I'm going to do the rest of it. It says that OD is 2X, okay? So that means is that O to A is X, so O to D is double that, okay? So it's going to end up there. Can you see that? There we go. So I'm going to put it there like that, and that is OD. And it also says that OC is 2Y, so OB is Y, so O to C will be double that, okay? So you can see, we're just going to write it like that. Now, what can you tell about this side here and that side there? I'm hoping it's really obvious, okay? But you should be able to tell they're going to be parallel, all right? And that's partly what this question is about, okay? Also, what do you think about the length of DC compared to the length of AB? Okay, it's double the length. Now you should be able to reason that already from what you've done with similar shapes, similar triangles in particular, okay? But if that length is twice that, if that length is twice that, then this length will end up being twice that and parallel to it. This question, if you like, is going to help us to prove that that is correct, okay? So we're going to kind of not assume that that and that are parallel, and we're not going to assume anything about the lengths, but we're going to go through the proof of why that is parallel and why it's double length of that. Okay, that's really what the question's about. So, to guide us through this, we're asked to first of all work out AB is, then OM, and then DC. And you can see once we've got DC, okay, we'll be able to compare DC with AB. In other words, we'll compare what those two are like, and then that will give us the proof. So AB first of all. Remember vectors, it's like pathways, trying to find a path from point A to point B. So A to B, so this way then this way. So it's negative X plus Y. Rewrite that as Y minus X, okay? And don't forget to underline your vectors, all right? O to M, right, so O to M is from here to here. So it's OA plus AM. I'm just going to write that down for the moment over here. So that's OA plus AM. So see how we split that up. OA is just X, all right? And A to M is half of A to B, all right? Half of A to B, and A to B was Y minus X, okay? So it's going to be that. So it's going to be X plus half Y subtract half X. If we expand the brackets, and then you've got X subtract half X, which is half X, and then you've got plus half Y. So I'm hoping you're happy with that. And when we write our final answer, we can just take the factor of a half out. So half X plus Y. So that is what OM is. All right. Next, DC. Okay. So DC. Now I know what the answer is going to be, but we can't write it down. We've got to calculate it. Okay. So DC, I'm going to go from here to here to here. If you want, you could go from here to here to here. Right, but I'm going to go all the way that way, then all the way that way. Okay. So from D to C, I'm going to go from D to O, and then I'm going to go from O to C. All right. As I said, if you want, you could do that if you wish. It's just that is 3 bits. So 1, 2, 3. The way I'm doing it is 2 bits. 1, 2. Okay. Now I know that OD is 2x. So DO, opposite direction, is going to be negative 2x. Okay, so that's going to be negative 2x there. And OC is 2y, isn't it? So that's plus 2y. Now I can write that answer as 2y minus x, like that. Okay, I'm going to put that answer there, 2 y minus x. Okay, and notice that was what I was expecting anyway. Okay, because what you'll see is that AB is y minus x and DC is double that. So can you see the fact that this is the same as this, but doubled means that the length is doubled and in the same direction. Okay, they are parallel as well. So what I'm going to do from this is I'm going to write down AB and DC are parallel. Okay, and also I'm going to write down DC is equal to twice AB. Now I can write that as vector form or length form. Remember, that and that are written as vectors with the arrow on top. When it's just that with no arrow, that's just a length. So it's asking us what to deduce about the length AB and DC. So it makes sense to write in the symbolic form DC is twice the length of AB. Okay, and that's a vector proof. That's a vector proof that these actually are parallel, and that is twice as long as the other. So that's just one of the instances why vectors is useful. It does help us to prove geometric relationships between shapes. Okay. I'm hoping that you understood that, and the next example will be coming up. I am about to go over example 7 now. That's on page 239, so you want to be on that page. Okay, I'll read out the example. So it says OABC is a quadrilateral in which OA is A, OB is A plus 2B, and OC is 4B. D is the point so that BD is OC, and X is the midpoint of BC. Find in terms of A and B, OD, OX, and then explain what your answers to those two questions mean. All right. Now, the diagram is drawn for an example, but it's not always the case. Okay, so when it says a quadrilateral, don't make an assumption. So I've just started by drawing it as a general quadrilateral. Most of the time, the quadrilaterals end up being a particular shape. A rectangle, or parallelogram, or trapezium are the general favourites. Okay, but you could have a kite or a rhombus. Okay, but it doesn't say anything about this. So don't automatically assume quadrilateral there means it's definitely going to be a trapezium. They've drawn it as a trapezium, I know, but that's only through reading the question. Okay, for the moment, just draw a quadrilateral that doesn't actually match any particular shape. Okay, so what we're going to do is we're going to have a look at the information given to us. I'm going to start to label it up. It says OA is A, so that's that. Okay, and then it says OB. Now remember, OB is from there to there. Okay, OB is A plus 2B. All right. What that means is from O to B, if it's A plus 2B, that bit there is A, so that bit there must be 2B. I'm hoping that makes sense to you. Okay, can you see now I've written it out like that? A plus 2B is OB. Okay, so I've deduced that from the information they've given us. Right, OC is 4B. This is the really important bit. OC is 4B. Well, if that is 2B, 4B must be parallel to that and twice as long. Okay, so that's where I'm going to refine my diagram now. So I'm going to rub that off. Okay, and that's why it ends up being a trapezium. All right, because we can deduce that this bit is going to be parallel and twice as long as that bit. Okay, so I'm going to label that as 4B like that. Okay, and I'll just join the two vertices together, and so that was ABC. Okay. And it says OC is 4B. Yeah, I've got that. Right, I'm going to do the rest of it now. D is the midpoint. Sorry, D is the point such that BD is OC. All right, so that is OC. Yeah, so it's saying that BD is the same vector as that effectively. So from B, I'm going to draw another one of those. Okay, so BD must be like that, such that that bit there is also 4B. Right? Does that make sense to you? I really hope so. Okay, I really hope so. And what else have we got? So, yeah, X is the midpoint of BC. Let's just put that in there. Mark it with an X. Okay, and that's it. We're ready to go. Notice we've not actually answered any of the questions yet. We've not answered like A or B, but that diagram has put us in a good starting position to be able to do that. Okay, so let's begin. OD, got to work out that is. So OD, from here, we go to OA and then from A to D. So that's A plus 6B. Can you see how labelling up the diagram has made it much quicker to do? Okay, the textbook, I think, just spends a bit too long on the working section. But once everything's all labelled up in the diagram, you don't have to write as much stages in your working, which I know will please some of you. Okay. OX is the next one. So what I'm going to do to get from O to X. Okay. So that's here to here to here to here. Okay. Now you could, if you want, go from here to here. That's up to you. Okay. But I'm just going to go from here to here to here. Okay. So what I'm going to do is I'm going to go from O to A. So I'm going to get rid of this book because I don't need to hold it, do I? OA plus AB plus BX. Okay. So OAB, AB, BX. Right. So OA is just A, and AB is 2B, and BX, that's going to be, well, I need to work out BC is the name. Okay, because we don't actually have anything for BC. So down by here, I'm going to write down what BC is. So from B to C, it is negative 2B, negative A plus 4B. Let's write that down. Negative 2B, negative A plus 4B. Okay, negative 2B, negative A plus 4B. Simplified, that is going to be 2B minus A. Okay, 2B minus A. That might be helpful later on. I don't know. So I'm just going to highlight that bit there. Okay. And BX is going to be half of that then. Okay. So BX is going to be half of BC. So half of BC is going to be B minus half A. Alright? And then if I simplify all that, so I've got 2B plus B, that's 3B. So let's write it in here, shall we? 3B. And then A subtract half A is half A. Okay? Maybe I'll just write it in alphabetical order, okay? Half A plus 3B, because it's nicer, isn't it? So half A plus 3B. There, that's a bit better. Okay, you see how it's done? Now, what else do we have to do? It's kind of almost it, isn't it? Part B, explain what your two answers mean. I thought it was going to be a bit more actually, but no, it's not. Explain what your two answers mean. Can you see what they mean? Well, when it says that in vector form, it usually means something like, are they parallel? Okay. Or can you say something about the relative lengths of each one? Okay. Now notice that OX is actually 1/2 of OD. Yeah. If you half that, you get this. Yeah. So OX is half of OD. Now, when you can write something like that, let's write it again. That OX is some multiple of OD, like half or quarter or twice or 3 times. Okay. Then that means that they're parallel. Okay. So I'm going to write OX and OD are parallel. Okay. And also, because that is exactly half of that, I can write a relationship between the lengths. I can say that the length of OX is half the length of OD. Okay, so I'm going to write it as OX is half OD. Okay, or you write OD is twice OX. Okay, and then I'm going to just have a quick look at the diagram just to make sure that makes sense. All right, so OD is that and OX is that. Okay, so if I join them up, OX and XD. Right, now I can see what's happened now. Okay, because I've actually done it on the diagram, I can improve my answer a little bit. Okay, not only are these two lines parallel, they must be the same line, mustn't they? Yeah, can you see that? Because of the way I've drawn it up, because I've started at O and then gone to X and extend it to D, okay, there's no way I could join that to that and then that to that and have those two bits parallel without it being the same straight line. Yeah, I hope that made sense to you. Okay, if not, just rewind the video again. Okay, I'm also going to write then that this means that O, X, and I'm writing out points now. Point O, point X, and point D. They're what we call collinear. Okay, collinear. Collinear means the points lie on the same straight line. Okay, so in my answer there, I've been quite thorough and I've covered every single thing. Okay, the OX and OD, they must be parallel. OX is half OD. Yeah, it looks like it's about half, so visually that seems to make sense. Okay, but more particular because it's because of this really. They've both got the same point in common, O to X and O to D. All points are collinear. Okay. Right, that was that example. I'm hoping that made sense to you.